My name is Chris Lee. My student number is S2248178878, and this is the Arduino LED control via a button. In terms of the hardware, we are using a lot of the same pieces with a couple of new additions. So it's the same microcontroller and the same breadboard. We've got a number of jumper cables, 2 LEDs, 2 220 ohm resistors here. In terms of new additions, we have 2 10k ohm resistors down the bottom here, these little brown ones, and 2 buttons. And the purpose of this circuit is to allow us to use buttons to turn on LEDs. So we'll have one for the blue LED and one for the red LED. In terms of configuration, the cathodes for the LEDs are wired to negative using blue wires. This is to ground the LEDs. So you can see these 2 blue wires here and here, and they correspond to the negative channel of the power rail. The anodes for the LEDs are connected to digital output pins 8 and 12, and we have current traveling across the 220 ohm resistors. For the buttons, we have buttons connected to 5 volt via the analog channel of the Arduino that uses this white jumper cable to connect to the power rail, the positive terminal of the power rail. In the previous video, we sort of spoke about how the main circuit board area of the breadboard, it runs horizontally. The power rail can run vertically. So we get 5 volts to the positive of the power rail, and then we have 2 purple jumper cables, and they connect power to our buttons. The the input signal for the buttons comes from pins 2 and 4, so that's these 2 black cables here, and that's on their digital channel. We have current traveling across the 10k ohm resistors, and that is going to give us a configuration with the default state of low or off. Now, the LEDs are set up in these 2 little parallel circuits, and LEDs, depending on the color, have different forward voltages, so we can actually determine how much current we're drawing for both of these parallel circuits. The red has a forward voltage of 2 volts needed to illuminate, and blue has slightly more at 3 volts, or 3.2 rather. Now with that, we know that both LEDs are connected to 5 volts via these black jumper cables. So if we were to say for the blue one, we had 5 volts minus 3.2 forward voltage, and then divided by the 220 ohm resistor, that would be equivalent to saying 1.8 volts divided by 220, and that would give us 0.082 amperes. Now 1 ampere is equivalent to 1000 milliamps, so if we times 0.082 by 1000, we would get 8.2 milliamps for the blue LED circuit. For the red, that had a forward voltage of 2, so it would be 5 minus 2. That would give us 3 volts divided by 220 ohm for the resistor, would give us 0.0136 amperes. And then if we times that by 1000, we would get 13.6 milliamps. In terms of the code for this program, we're first going to declare a number of integer constants. Now, each of these values is going to correspond to a pin, excluding the power to the buttons via the analog channel and the power rail. We are using the setup function this time, and we're going to use it to initialize our settings. So we'll have LED 1 and 2 configured as output, and the idea here is that we're going to be sending voltage to turn them on and off. We're not sending instructions or anything like that, so they're not input. And then in our main, we are setting the buttons as input as well, though, before I move on. In the main loop function, we have button state 1 and 2, and the idea here is that we're going to capture the initial state of the buttons, which will be unpressed, and we'll pass that to digital write with the LED 1 and 2 variable. And the idea here is that when we press a button, it's going to update the state, and that will set the state to high, and then that will be passed with the corresponding LED, and then that will turn our LED on. Thank you.